Okay, last lesson for today, 6-4, geometric sequences. Okay, if you look at this example here, a seating plan is behind, designed for section 12 of a new stadium. Notice how row A has less rows compared to row E. Let's count the number of seats in each row. Okay, row A, 2. Row B has got 5. Row C, 3, 4, 5, 6, 7, 8. Notice how we have 11, 14. You're adding by 3. So this is arithmetic because you're starting with 2 and you're adding with 3. Voila, you got it, okay? So we're going to skip part C. That's arithmetic. But now we need to talk about geometric. Geometric means multiply. Okay, so when we're finding the next number, we are multiplying to get to the next number, not adding. So that definitely changes things for sure. Okay, that definitely changes things for sure. So we need to look at this here. We need to see if each sequence is geometric or arithmetic. Okay, we need to divide like we did from lesson 6-2, we need to divide the previous numbers to see if we can get the next number, or if it's consistently multiplying by the same number. So notice here, 2 divided by 3, 2/3. 4/3 divided by 2, 2/3, 2/3, 2/3. So it's geometric. Okay, this one here, it's arithmetic because notice here we're adding to get to the next number. Boom, 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 boom. It's not geometric, it's arithmetic. So in this case, we're adding by 1.5. Let's look at this one here. 2.2 divided by 1, that's 2.2, okay? 4.84 divided by 2.2, okay? If you want to be technical here, let's use Desmos, okay? Boom, and boom, whoop, and boom, okay. 4.84 divided by 2.2, 2.2, voila. So therefore, it's geometric. Okay, this one here, it's not. Okay, you're adding by 74 to get to the next number for each of these. So this is arithmetic. Again, geometric, you're multiplying. Arithmetic, you're adding or subtracting to get to the same number. Okay, next one here. Now let's write a recursive formula. It's actually easier, in my opinion, than the arithmetic one because you need two things. What you're multiplying by and then the previous number. For the first number essentially, okay? So for this right here, to find the recursive formula, you need to find out what the first number is and then what you're multiplying by to get to the same number. So notice here, you're multiplying by 3/2 to get to the same number. The first number is 8. And how do you get the previous, or the multiplication of the previous number? Divide 12 by 8, boom, 3/2. That's simple. Let's look at this one here, okay? So the first number, okay, that's gonna be 3072. Now let's find out how we get to the next number. Okay, so we're going to go 768 divided by 3072. Here we go. 768 divided by 3072, 20.25 or 1/4. Okay, we can say it's 1/4. So 768 divided by 3072, that's equal to 1/4. So that means it's 1/4. There you go. So this is your recursive formula. Arithmetic, however, is a little bit different, okay? Sorry for, wow, what am I thinking? Explicit. First number, common ratio. Bing, bang, boom, you got it, okay? So the same thing up here, okay? Knowing that we need to find the 10th term, we just have to find the equation for this. First number is 8. We're multiplying by 3/2 to get to the next number. 10 is what we're looking for, the 10th number. We then plug it in, okay? Here we go. 12th term in this. Initial condition is 3, and to find the next number, it's multiplied by 6. So my equation is 3 times 6 to the n minus 1, or to find the 12th number, 3 times 6, 12 minus 1. Let's find it. Let's use Desmos for this, okay? So 3 times 6, and then power of 12 minus 1, there you go. It's a big number, okay? That 10 in the 9th means I'm moving the decimal 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's actually all of this with the decimal all the way at the 7. So it's 65303. Let's write it down. 65303. 47007. You go. Voila, you got it. Okay, have a long ways to go. Here we go. For this one right here, the number of subscribers, you're starting off with 5, but then how could the trend subscribers be modeled? And you're doubling each week. So you're starting with 5, you're multiplying by 2 to get the next number. There's your equation. Boom. For this one here, how many subscribers will there be in week 9 if the initial subscribers is 10? Well, let's make the equation. 10 times 2 to the power of n minus 1. Plug in 9 in for n. Let's find the equation, okay? So it's going to be 10, 2, and then 9 minus 1. Oh, shoot. I need to put a parenthesis around this. 9 minus 1. There we go. So it's 2,560. That's how many subscribers there are going to be in the 10th week, in the 9th week. So it's 2,560. Voila, we got it. Okay, here we go. Next one over. The number of people attending the annual Town International Food Festivals decreased 20% every year. How can the attendance for the first 5 years be modeled? Believe it or not, we've got it, okay? So you're starting with that many and you're losing 20%. So that means you got to multiply by 0.8, okay? So then we've got our equation. So it's going to be 1250. 0.8 to the power of n minus 1, okay? If the trend continues, what's the attendance in 10 years? Well, plug in 10 for n, boom, you got your answer, about 167 or 168, okay? So this formula right here, starting off with 40, describes a sequence. Use the explicit formula to determine the 5th number. Let's write the equation. 40, 1.5, n minus 1. We're going to change n to 5, plug it in, we got it, okay? So in this case, 40 times 1.5 to the 5 minus 1. Let's figure it out. Let's put a parentheses around this to close that just in case. Okay. 40 parentheses 1.5. Okay. Power of 5 minus 1. Voila, 202.5. After all that's said and done. Voila, we got it. Okay. That covers that there. Let's look at the last example. Actually, that's it. I must have repeated a page. Know this, explicit recursive. Know the different ways of doing it. This is not a hard lesson. Definitely follow along. That'll cover it here. Enjoy.